Okay, hi everybody, this is Mrs. Pesic here, and I am live with my Block 7. You want to give a shout out, Block 7? Okay, alright, sorry, I'm just kind of forgetting to start this up, so let's do a little recap of what we've learned so far in section 3.3. We learned that you can change a base if you don't like the base. So we did log to the, oh, you can't see what I'm doing because this is frozen.
Don't like the base, get it out of here. We don't need that base. Let's change it.
So if you don't like the base that you have, like if you don't like log to the base 2 of 7, you can rewrite it with whatever base you want. But you have to take the 7 and the 2, put them in the numerator and denominator, and then choose a base, like base 10 or base E. So I could write it as ln of 7 over ln of 2. All right, then we did some problems from the homework from 3.2. All right, and then we talked about, we skipped that. And then we talked about some of the properties of logarithms. We said that if you are going to multiply two things together in a log, you can split it up and write them as two separate logs, but you have to add. And we said the same thing happens with a quotient. If you take log of to the base a of u over b, that's the same as log of u minus log of v. And we did some examples like that. So you could pause this video and take a look at those examples. And then we looked at the power property, which says log to the base a of u to the n is the same as bringing that n down in front and writing it as n times log to the base a of u. We looked at this example, which you might want to pause the video and take a look at that. All right, then we did a few examples where we did ln of 10, and we wrote that in terms of ln of 2 and ln of 5. So ln of 10 can be written ln of 2 times 5, and then we can split that up and write that as ln of 2 plus ln of 5. And we did another example like that, so you might pause this video and take a look at that. Okay, and then we are on these problems right now where we're finding the exact value of each expression without a calculator. So what do you have for letter A? 1/7. Did you rewrite this as log to the base 5 of 5 raised to the 1/7 power?
Oh, yes, we did.
And then did you use the power property which says that we can bring this 1/7 down in front?
Yes.
And write as 1/7 times log to the base 5 of 5. What is log to the base 5 of 5? So that's just 1/7 then times 1 gives us 1/7. Hands please. How are we going to do this letter B? Matthew?
1-to-1 property.
How so?
They have the same base E. What are you doing? Do not let Lance answer questions.
Can we use the power property here? Yeah. So if I'm going to use the power property, that means this can be rewritten how? Morgan?
Let me down.
So 12 times log to the base E of E? So that's 12 times log to the base E of E. What is log to the base E of E, which is the same as ln of E?
It's like 1.
1. So I get 12 times 1, and then over here, this one would be 5 times ln of E, which is 5 times 1, which is going to be 5. So I get 12 plus 5 is 17. Is this okay?
Yes.
All right.
Wouldn't the 1-to-1 property work? They both have the same base E.
We're not solving, so I think the 1-to-1 property is basically in terms of solving. Okay? All right. Welcome, friends.
Welcome.
Welcome, friends.
Welcome to
Okay, so let's move on. We are looking now at solving. When you need to solve logarithmic equations, it is often helpful to rewrite them in a different form. We'll call that expanding or condensing. In this case, we're going to expand this logarithmic expression, log to the base 4 of 3x squared y. So think of this whole thing in the parentheses here. So I can really split this up into log to the base 4 of 3, log to the base 4 of x squared, log to the base 4 of y, and what operation do I need in between? Griffin?
Addition.
Addition. Are we okay with this? This is expanding. I expanded it. I wrote it as a bunch of different logarithms. And then the only thing I would do is I would simplify this guy further. How would I simplify that one further? Griffin?
2 times log base 4 of x.
All right. I'm going to bring that 2 down in front. So I'm going to have log to the base 4 of 3 plus 2 times log to the base 4 of x plus log to the base 4 of y. Are we okay with this?
I have a question.
Yes.
In section 3.2, did we learn that like when there's an exponent in the log, that's just a weird answer?
Only if this base was equal to this number. So if you look back, you'll see that we said if it's log to the base a of a to the u, it's just going to be u. So these numbers would have to be the same. Okay? All right, let's take a look at expanding this one here. We're doing ln of square root of 4x plus 1 over 8. And would you please take a moment to expand this one? Steps.
Okay, so I rewrote it as ln of the square root of 4x plus 1 minus ln of 8. And then with that square root, I rewrote it as 2 times ln of x plus 1.
But this square root would be 4x plus 1 raised to what power?
So 1/2.
1/2 minus ln of 8. And then you're going to use a power property.
Yeah,
So what are you going to put out in front?
the 1/2 there.
So 1/2 times ln of 4x plus 1, I'm going to keep that in parentheses, minus ln of 8. We have expanded the logarithm. Are we okay with this?
So that's your final answer.
That's it. I don't think we can expand it any further than this. Let's take a look at some examples of condensing. So this is going the other direction. So talk me through this. What should we do first? Lily? If I've got a 1/3 out in front, that's...
Oh, that's it. So log of x to the 1/3.
to the 1/3 power. And then what about this one?
Log of... Is this one of the properties?
Once again, it's something that's being multiplied out in front.
So... to the... wait. X minus 3 to the 5th.
Do people agree with Lily?
Yes.
All right. Then what? Because we're not done yet. What would be the next step here, Nathan? I've got 2 logarithms and I'm adding them together. How can I rewrite that as 1 logarithm using one of our properties?
The product.
All right, use the product property of logarithms. So I'm going to write this as what?
Log of x times 1/3 times 5, or right?
So x to the 1/3 power? Right? Don't we have log?
Yeah, and then
and then
times x minus 3 to the 5th.
Are we okay with this? I think.
Could we take the cube root of x?
And I was just going to suggest that maybe we want to take this one step further and write this as log of cube root of x times x minus 3 to the 5th. Likewise.
Good job, Lance.
Are we okay with this? And those are being multiplied. Let's try one more of those. If we have 4 ln of x minus 4 minus 2 ln of x, how are we going to rewrite that? We're condensing. Griffin?
Well, you see, you'd first start off with your, yep.
I do see it. Do it.
I do see, yes.
What are we doing?
As soon as we took ln into the equation, my brain just shut down. It's just like, what is this?
All we could do this is that ignore.
Well, I've got 4 times a logarithm.
So I guess just take it to the 4th.
So what am I going to write?
ln of x minus 4 to the fourth
Okay,
minus 2 ln x
okay, how can I simplify 2 ln x?
minus ln x or ln x squared.
Are we okay with this? All right, and then how do we go one step past that? Connor?
You do ln of, you use the quotient property, so it would be ln of x minus 4 to the 4th over x squared.
Are we okay with this? All right, and
Oh my gosh.
let's
That's it?
take a look at this one.
Where's the other parts of the problem?
What do you mean, where's the other parts of the problem?
Where did
That's like nothing.
Too easy? Can we handle just that part first? Let's leave the 1/5 out of it for right now. Greg?
Oh, yeah, I was hoping that wasn't gonna happen.
What is it?
We could do, log base 3 of x plus the quantity x minus 2, or I'm sorry, times quantity x minus 2.
Oh my gosh, Greg.
I almost dropped the ball there, but I didn't.
Like this?
Yeah.
Do people agree with that?
Sure.
And we still had this 1/5 out in front of this? So if we got 1/5 out in front of a logarithm, how can we rewrite that, Morgan?
We have 5 of the exponent after the big parentheses.
So I want log to the base 3 of x. Well, I mean, I could distribute this, I guess. You get x squared minus 2x. And then what?
The 5 as an exponent.
Raised to the 5th?
Oh, 1/5.
Raised to the 1/5? Do people agree with that? And then we could always write the 1/5 as in a radical form. So wouldn't that be like a 5th root of x squared minus 2x? Now that's condensed. Does this look okay? David?
There's notes online.
Yeah, and better than that, I'm recording this lesson right now as we speak. All right? Okay. Questions on this? Okay, what else can we talk about? I'm going to skip this example. I know, in interest of time, I'm sorry. It's kind of cool, but no. Okay, so at this point, let's take a look at section 3.4.
I don't even know what 3.1 and 3.2 are anymore. I mean, I didn't really know much to start with, but now it's all done now.
Come on now.
We did like 5 minutes review.
We did 5 minutes review at the beginning of class.
I know, we did right.
What are we looking at, 3.4?
I've been studying for the pushing standards.
Is your recording my?
No, Chris,
Mom, this is gonna be on YouTube.
Don't call me that. Don't call me that. Okay, couple quick examples of problems from section 3.4. 3.4 is called exponential and logarithmic equations, and this is where we're going to learn to solve exponential and logarithmic equations. For this problem right here, if I want to find 2 raised to the x, if I got 2 to the x equals 15, and I want to solve for x, I'm going to need to rewrite this in another form. What am I going to write? Matthew.
Log of base 2.
So log to the base 2 of 15 equals x. And then you would grab your calculator and you would do log to the base 2 of 15. And if I gave you a TI-83 or a TI-84, you couldn't do that directly on your calculator. You would have to use the what?
Change of base formula.
Change of base formula. But for right now, what is log to the base 2 of 15?
3.9.
So x is approximately 3.9. Are we okay with this? All right, so that's an example of solving an exponential equation. What about this one? If I want to solve ln of x minus ln of 5 equals 0, what would I do first? David?
Can I make a guess? Sure. Okay, and then you get a guess based on what I heard from class. What you just have is the ln times x over 5 equals 0.
You mean ln of x over 5
Yeah.
equals equals, you could use the quotient property to rewrite it like that. Then what?
So,
If I see ln, that's understood to be what?
log base.
Log base e. So I have log to the base e of x over 5 equals 0. So how am I going to solve that? Greg?
Would you set x over 5 equal to 0? I don't know, that would
Would
be
you
fine.
multiply
Never mind.
a 1
Can we make
over
0,
x?
1, and then that'd be correct?
Can we back up for a second? How did we solve this problem? We had an exponential problem to solve, and so we rewrote it in log form. So often in this section 3-4, to solve an equation, you're going to rewrite it in the other form. So if it's an exponential form, chances are you need to rewrite it in log form. If it's in log form, chances are you're going to have to rewrite it in exponential. Not all the time. Sometimes you don't have to do that, but it is often helpful. So here, can I rewrite this in exponential form?
Yes.
Matthew Fazio, what's it going to look like?
E to the 0 equals 1 x over 5.
Equals x over, do people agree?
Yes.
And that means what is e to the 0?
1.
So I get 1 equals x over 5.
So x must equal 5.
Are we okay with this?
Didn't know that.
Keep it up. So x equals 5, are we okay with this? All right?
This is no bueno.
Why not?
Yeah.
5, 10, maybe 10 minutes. I get 10 minutes. Okay, let's take a look at this example. This one is 1/5 raised to the x equals 125. What are we going to do to solve this one? I am calling on you, David.
Great. It would be, you would have to put it into logarithmic, however you say that.
Logarithmic form.
So I'm going to go ahead and say log of base 1 over 5. Of 125 equals x.
Actually, you know, there's nothing wrong with doing what David said, and I was actually going to go along with you completely on this. But I think for this particular problem, this one might be better with Matthew's favorite one-to-one property.
There we go.
So in this case, can we get both sides of this equation? Can we bypass this strategy? And instead of this, can we rewrite it so that both sides have the same base? What base might that be? 5. So I can write 1/5 as 5 to the what?
5.
-1, but that still is getting raised to the x. Agreed? And what about the 125? 5 to the 3rd. So I have 5 to the, I've got to multiply these, right? -x equals 5 to the 3rd. My bases are the same,
Oh my gosh.
so the exponents have to be the same. So x
3.
equals -2.
Oh my gosh.
So this one, we did not have to rewrite it in log form. David?
If that, what we just did confuses us, can we write it in log form? Because I understand that log form.
I think that my directions would probably say use the one-to-one property, and that's where you got to get both sides to have the same base. Okay? All right, and let's take a look at this one. E to the x equals 13. What are we going to do to solve this and?
Should we write it in log form? So, right?
Yep.
Okay, so log to the base e. So is that ln?
Uh-huh. So log to the base e of 13 equals x, so that's the same as ln of 13 equals x. Agreed? All right. And then you could just type that in a calculator and get a decimal approximation. So what is that? That's e raised to what power gives me 13? 2.56. So x is approximately 2.56. Are we okay with this?
Or
All right. And how about this one? ln of x equals -8. How are we going to go about solving this one? Abby?
Wait,
Should we what?
what is exponential for?
Go for it.
Okay, so, well, if you wanted to just like write it in log, I'm gonna be like ln, or log to the base e of x is -8.
Okay?
So then, if you make it in the exponential form, it would just be e to the -8 equals x, right?
Do people agree with that? All right, calculators, what is e to the -8 approximately? I mean, this would be your exact answer, but if we want a decimal approximation, that's going to be what?
0.000335.
Or you can say it's 3.35 times 10 to the negative.
Oh, your scientific notation.
Are we okay with this?
Ooh.
Questions on this? David?
Is it permissible to write 3.55 times 10 to the -4?
Sure. That would be A-okay. All right, let's try something that's more interesting.
Yeah.
That looks interesting to me. Yeah, I like this. That's it. Property right there. That's what I mean.
Does it look like a one-to-one property?
It's a quadratic.
So how are we going to solve this one, Matthew Armstrong?
Negative x squared equals 5x plus 6.
Negative x squared equals 5x plus 6. Matthew's noticing that they both have the same base, which means these exponents must be equal, so we set them equal to each other. What kind of equation are we now solving?
Quadratic.
Quadratic equation. I would add x squared to both sides and get x squared plus 5x plus 6.
Okay.
And does that factor?
Yeah.
Plus 6.
So I get x plus 3, x plus 2. Does that look okay? And so I set these equal to 0, and I get x equals -3,
X equals -2.
and x equals -2.
So how do you know?
I think both of them should work, right?
That's okay.
Are we okay with this?
I'm sorry.
And,
Time is a
whoa,
waste of money.
Oh, no. I don't think I like that.
Yeah, that's it.
all right, last one, and then we're going to talk quiz, okay? And for this one, this is problem number 9, so don't count that. All right? What would be our first step in trying to solve for x here? Matthew Fazio. All right, so subtract 5 from both sides. We get -3. E to the x equals -3.
No way.
Then what?
How we divide into 3?
Divide both sides by -3. So we get e to the x equaling 1.
Yeah.
And then what?
Well, I mean, you can, I mean, x
Oh my
1 is
gosh.
0, but you can probably do log to the base e. 1.
Okay, log to the base e of 1 is equal to x. And what is log to the base e of 1?
0.
E raised to what power of 1? 0. Are we okay with this?
We didn't need to do any of that. We could have stopped right when we got to the e to the x equals 1.
So you're saying e raised to what power equals 1, and you're saying you would have known.
Yes.
Well, everybody knows. Everybody.
Okay, here's, okay, let's talk about this, quiz. We got a quiz on 3132, okay? It's in 2 parts. Part calculator, part non-calculator. Here is what I would like to offer you the chance to do. Okay? You can, well, I still want you to do the non-calculator part by yourself. But have we had a partner quiz all year?
No.
Ever?
No.
Ever.
No, we didn't want.
So your last quiz of the year, I'll make the calculator part partner. But
I need a smart partner.
you may, but I think that the 4 people that came in late, can somebody, I mean, take one of them. I don't think that they should necessarily be grouped up because we did talk about how to find vertical asymptotes at the beginning of class and domain and so forth. All right? Do you know who you're going to partner up with?
Greg? No? You're probably.
I don't know if you're going to.
Jesse, you want girl power?
And we have an odd, if you want to take it by yourself, I'm certainly not going to force you to take it with a partner.
And Novak, hit me up.
All right?
Yeah.
However, if
The two
I do
smartest
have
people are working together, that's not fair.
I do have an odd number of people in the class, though, correct? There's 17 of you in the class, so I can have one group of 3, but only if everybody else has a partner. If somebody else is by themselves, no group of 3. You with me?
I understand.
Yes?
Yeah.
Okay.
Yeah.
I don't know, I
So
kind of.
raise your hand if you're planning on taking this solo.
That's really funny.
Nobody? Everybody has a partner?
I got Novak.
All right, so at this time, I need you to put your calculators on the floor, because we're doing the non-calculator part
It's not
first.
quickly.
Calculator on the floor.
This is it's non-calculated because I don't know.
Doing them in the wrong order.
And put your calculator in your hand here.
Well, one of these. You know 3.2, and I have to take.
Listen,
That makes up all of us.
Everybody around.
Are we all good? Calculators are up here, they're in front of the test. I'm checking to make sure you're in front of the test. Your phone and your lid are up here also. Let's go, people.
Jeff.
I remember to take next test.
I calculated.
My partner's knowledge and I just forgot all of the stuff that
So
I
I've got
remember.
20 piles. You're supposed to stack your phone with your calculator. Calculator right here. What? Who's this? Is that you? You? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. David, slide over. Great.
I don't know what I'm doing.
I wasn't here Monday.
Can I have the talking stop, please?
How many points was on a calculator?
Can you please add on number 6 and 7?
Yeah, great.
ln of e and ln of 1. You're just giving me the values for ln of e and the ln of 1.